We stop at example 7 previously. We start at example 7. Right, this example 7 talks about the two fair dice being thrown, right, and then they ask you to find the sum, okay, exceeding 10. So this is event A, this is event B. So they are asking you to find probability A given B. Right, we learn this conditional prob. The given is a vertical straight line down. Okay, this is called given. Right, and we have already shared with you what is the keyword that you need to take note of. The keyword is the given there. Alright, so this is the conditional prob. Okay. We went through, okay, event A intersect B, so it's getting a sum of 11, right? The first die showing a 5, second die showing a 6. That gives you a sum of 11, which exceeds 10, right? Whereas for event B, is the score of the first die to be 5. So if the first die is 5, okay, the second die can be 6 or 5, oh sorry, 5, the second die 1. First die 5, second die 2, first die 5, second die 3, and so on until 5, 6. Okay? Right, which I circled horizontally. So if you want this, probability A intersect B will be, there are total how many outcomes? 36 outcomes. In your event A intersect B, there is only one outcome. So 1 out of a total of 36 outcomes. Divide by, in event B, how many outcomes are there? 1, 2, 3, 4, 5 until 6. So there are 6 out of 36 total outcomes. So this gives us 1, 6. Alright? Okay, who is confused at this point in time? Okay, I remember the last lecture I asked you, go through this example on your own first. It's not too difficult. Okay? So this is 1 out of 6. Okay, let's move on to example 8. Okay, example 8. So let's read this example 8. Okay. I travel to work by route A or route B. The probability I choose route A is a quarter. And the probability that I'm late for work if I go via route A is 2/3, and the corresponding probability if I go via route B is 1/3. Okay, so what this means, this one, you see, there are sequence, right, of stages. So before I move on, right, you must first think of the method to solve this. Okay, very likely it is tree diagram, using a tree diagram. So let's draw out the tree diagram first. Okay, but before I draw a tree diagram, you need to define your events. Right, every example I ask you define. Please remember that. Okay, so for the tree diagram, at the end branch is A, the probability should be on the branch itself. So if I go via route A, okay, A is traveled by route A, B is traveled by route B, L is late for work. Okay, so this is what I define the events to be. So if I travel by route A, it's a quarter. This is what it means by the first sentence. The probability that I'm late for work if I go by route A is 2/3. So here will be 2/3. Because if travel route A, late for work. This is actually probability L given A. Okay? This will be 1/3, this branch, because it's probability L prime given A, which is 1/3. Okay, let me zoom in bigger for you. Okay? If I travel by route B, the probability will be 3/4. this would be probability L given B. This would be 1/3. Okay, because they travel via route B, late for work is 1/3. Okay, this is the last sentence, okay, of the example. And this is probability L prime given B is going to be 2/3. Okay, I write down the conditional probability, like probability L prime given B for you, so that you understand that this is a conditional prob. Okay, so probability, example 8, right? Okay, so probability that is late for work on a Monday. Okay, so if you want them to be late for work, you'll be this branch and this branch. Okay, so be a quarter multiplied by 2/3 plus 3/4 multiplied by 1/3. Right, it will be 5/12. Okay, pretty straightforward. Okay. Okay, next part. Okay, next part, part 2. Given that, okay, let me highlight the keyword. Given that I am late for work. So, given that, the keyword is given that. So, remember, it's a conditional prob. So, given that I'm late for work, event is Li. Probability the event via route B is B. So, what are they trying to find? Okay, they are actually trying to find probability B given L. Okay, given that late for work. So, the given that, so you should find probability B given L. Okay, so this is what it means. Okay, what is the formula for probability B given L? Let me ask. So let's just now you were thinking very hard. Right? Even you close my eyes for 10 seconds, I also know. Okay, what is the formula? B given L. Probability. Conditional prob formula, don't know. Quickly, come. B intersect L over probability of L. Okay, this is the formula. The next time I ask you, you don't know, you write 5 times. Okay, so probability B intersect L, where is B intersect L? Okay, B intersect L is already circled for you. Here will be 3/4 multiply by 1/3 divide by this, the bottom will be part I answer 5/12. So this gives you 3/5. Okay. Sorry. Okay, written now. Okay. So this is part 2 is conditional prob. Okay, let me share with you something. Okay. Let's say I phrase part 2 in such a way. I rephrase part 2. I am late for work. What is the probability that I went via route B? It gives you a statement. I'm late for work, to stop. What is the probability that I went to work via route B? Okay, you realize that there's no keyword, right? I said given that is the keyword for conditional prob. Okay, but in this keyword, But in this case, there's no keyword, right? This still means probability B given L because they tell you this statement: I am late for work. Right? It means that they tell you, means given that you're late for work, what is the probability to go via route B? Clear about that? Okay. So please take this down because you encounter this kind of question. Okay. This part 2 and this part 2, they are the same. It means they want you to find the conditional prob. Is this clear? Okay. Okay. Please take it down. I like to give you a lot of tips and hints so that when you do tutorial, it's much easier for you. Okay? And when you do tutorial, right, it's also good. It's a must or not good. It's a must to look at your lecture example and do some matching, which are similar concepts. Then can help you with your tutorial. Some of you do tutorial without looking at the lecture notes, knowing that you know everything. That's not the case. At the start, you need to refer to lecture notes. And some of you don't know how to study on. But this is what I share with you. Okay? So this is example 8. This is also a conditional prob for this one and also for this one. Okay? Okay, so this is for example 8. We are done with 8. Let's move on to example 9. Okay, let's take a look at example 9. Okay, A and B are events. A prime denotes complementary event to A. They give you certain information. PA is 0.4, B given A is 0.7, A prime intersect B 0.3. You notice that there are no stages, so I don't use a tree diagram. Okay? They only give you such events, so likely is Venn diagram. Okay, so Venn diagram. Right, so this is my thought process. When read the question, are there stages? No stages, tree diagram likely out. Likely out. Okay? Then I'll draw a Venn diagram to help me visualize. Okay, please take note. Conditional probability can never be represented in the Venn diagram. Is that clear? Conditional prob can never be represented in the Venn diagram. Okay? But this conditional prob, okay, we can apply the formula. This is B given A, right? Is B intersect A divided by probability A. Okay? Okay. So for part 1, okay, B given A, B intersect A divided by probability A. Okay, you got this to be 0.7. So probability B intersect A will be divided by 0.4. Because given in the question. So this part does it give you? B intersect A to be 0.7 times 0.4, 0.28. Okay? So whenever you see conditional prob, your formula, you must be sensitive to the formula. Okay? You must remember the formula. Alright? Okay, for part 2. Okay, people leave some space on the right. Later on, I'm drawing the Venn diagram. Do you have a Venn diagram on in your book? No. Okay, I'm going to draw a Venn diagram later on. I'm just preempting you first. Leave some space on the right. For part 2, find probability B. Okay, so let's see what probability you have. You only have, is PA useful to find probability B? Not at all, right? Probability A to find probability B is useless. You can use probability A prime intersect B as well as probability B intersect A. How? Let me draw a diagram out for you. Okay, on the right hand side, the Venn diagram. Okay, event A, event B. Okay, where is A intersect B? The center part. A intersect B. Where is A prime intersect B? We're going to use green. A prime intersect B will be here in green. Is it clear? So, see, I draw a Venn diagram easier for you to see. So, probability B is in fact write down probability A intersect B plus probability A prime intersect B. So it's like playing jigsaw puzzle. So you add them up. So this gives you 0.28 plus 0.3, 0.58. Okay? Right? Draw the Venn diagram. I'm giving you time to draw. Use pencil to draw, don't use pen. All diagrams should be drawn in pencil, in math. Okay? Part 3. Okay, they want you to find what? A union B. Okay, this A union B, I forgot something. I haven't gone through section 4, right? Right? This A union B is actually section 4. Okay, so please take note of this formula first. Okay, I'll go back to section 4 in a while. A union B is probability A plus probability B minus probability A intersect B. Later on, we can investigate why, but just take down this formula. This is formula. So PA will be 0.4 given in the question. Probability B, you found it in part 2. A intersect B, you also found it in part 1. Okay, so this is in the question. 0.58 is in part 2. 0.28 is in part 1. Okay, you see, you realize that once the one of the part you got it wrong, the whole question is wrong. Okay, because they are all linked. Okay, so this gives you 0.7. Okay, I got part 4, so I'm going to write on the right hand side. Probability A given B. What is the formula? Okay, probability A given B, what's the formula? Pardon? What's the formula for A given B? A intersect B divided by probability B. Okay, so A intersect B 0.28 divided by 0.58. 0.28 is found in part 1. 0.58 is found in part 2. Okay, 14/29. Okay, so this is for the last example for conditional prob. Okay, I'll move back to section 4. I missed out that one part. Okay, don't worry, it's a small section. Okay, people, section 4. Okay, this is the formula. Okay, A union B is PA plus PB plus minus A intersect B. How do we get this formula? Okay, how do we get this formula? This is example for the Venn diagram that is drawn. I'll explain from the Venn diagram. Okay, A union B, what does it mean? A or B. A union B is A or B. Okay, meaning is R plus T plus S. Do you agree with me? A or B? R plus T plus S. Either A, not B, A and B, or B without A. Okay? Whereas for probability A is R plus T. Probability B is T plus S. Probability A intersect B is T. You notice that if I add up PA plus PB, you got R plus 2T plus S. You get R plus T plus S. What must you do? You need to subtract the part that is in the middle, which is the T. Okay? So therefore, this one is A plus probability B subtract A intersect B. Okay? I repeat again, PA is R plus T, PB is T plus S, A intersect B is just T. So we add up PA plus PB only. We got R plus 2T plus S. You double count the T. So you subtract one more copy of it. Is that clear? Okay? This one might be slightly different from what you learned in secondary school, right? Okay. What you learn in secondary school is this. You learn in secondary school is when what you learn is mutually exclusive events. Mutually exclusive event means they cannot occur simultaneously, meaning probability A intersect B is 0. Agree or not? Means they don't intersect at all. This is mutually exclusive. The Venn diagram shows mutually exclusive. So if I were to use the formula, this A union B, PA plus PB minus probability A intersect B. This formula is super important. If they are mutually exclusive, this will be 0. If A, B are mutually exclusive. And so A union B will be PA plus PB only if A and B are mutually exclusive. Clear about that? Okay, they do not intersect. Only if they don't intersect. Okay, so this is for section 4. Okay, pretty simple. What are some examples of mutually exclusive events? Okay, these are some examples. A coin is tossed. Okay, obtaining a head and obtaining a tail, they are mutually exclusive. Okay, means it cannot happen together. For part B, I draw a card. If I have to draw a card and the event of drawing an ace, they are not mutually exclusive because we can intersect. We can draw a pair of cards, right, contain the ace of hearts. So this is not mutually exclusive for part B. Okay? Okay, so I've explained to you when is it mutually exclusive, when is it not mutually exclusive. Showing you examples. Okay, I'll move back to section 6. Okay. Independent events. Okay, this is a pretty new concept. Right, independent events. Give you an example. Okay, a pair die is shown once. A denotes an even number. B obtain a number less than 3. So if I were to list down all the event A, this will be event A happening. The outcomes is 2, 4, 6. A prime will be odd number, so 1, 3, 5. Event B obtain a number less than 3, so it's 1 and 2. How I'm trying to do what it means by independent later on you'll see. So I want to find probability B intersect A, which outcome occurs both in A and B. Is obtaining a number 2. And okay. Next, I'm going to find out the probability of B given A. Right? Probability of B given A will be the number of outcomes in B intersect A and the number of outcomes in event A. So B intersect A, there is only one outcome. Number of n outcomes in A, there are only 3, so 1/3. Okay, clear about that? Okay, B given A, if it's 1/3, so I tell you A happens. What's the probability B happening? 1/3. Let us move on to B intersect A prime. B intersect A prime is 1, 3, 5. Which outcome occurs both in A prime and B? To be the number 1. So B given A prime using the formula, number of outcomes in B intersect A prime divide by number of outcomes in A prime. This is also 1/3. The probability of B happening is also 1/3. Okay? Do you notice something? The probability is the same throughout. Okay? You notice something that the probability is the same throughout? It's all 1/3. What does it mean? Okay? This means that no matter whether A happens or not, it doesn't affect event B. Okay? So this is what it means by the star. Right? The event B, what's the probability of B happening? Given A or given A prime is not affected by the event A itself. Okay? This is what it means by independent. Okay? So this is an important concept. You will always have this independent events. Right? Okay? So in general, okay, if for any events A and B, the probability of occurrence of one of them is not influenced, meaning they don't affect the other event. Event A and B are called independent events. How do I prove independent events? There are 3 conditions. These are the three things to prove independent. Okay, you don't have to prove all 3. Okay, you just pick one to prove independence. condition 1. Why is this happening? If they are independent, right? Probability of A happening, given that B happens, since they are not affected, it should be the same as probability A. Clear about that? Likewise, for part 2, it's the same reasoning for part 2. Okay. For part 3, if probability A intersect B, you show that it's PA times PB. Okay. Why do I have this? Okay. If you recall, this is the formula. Probability B given A is probability B intersect A divided by probability A. And then multiply the PA over, you'll get this. Okay. If AB are independent, then PA times PB given A is PA times PB. Alright? Because B given A is PB now. A by condition 2. Right? The I part II. Right? So this is what it means by independent. Okay, so pick one of the three to show independence. I think if you go straight to example would be better. Okay, later on, go on first. Okay. Right, have you written down? Okay, let's move on. Okay, to some footnotes. Okay, condition footnote 1 is the one that I told you already. Just pick one of them. Right, to prove. Footnote 2, okay. If PA and PB is not equal to 0, events A and B cannot be both independent and mutually exclusive at the same time. Why? Okay, this one is just for own enrichment. Okay, if A and B are independent events, what happens? PA intersect B is PA times PBI. Correct? Agree or not? If they are independent, PA intersect B is PA times PB. But since each of them is not equal to 0, that means PA times PB not equal to 0, right? If it's not equal to 0, A and B are not mutually exclusive. Okay? Alright? So if A and B are independent, A and B cannot be mutually exclusive. Likewise, if A and B are mutually exclusive, meaning PA intersect B is equal to 0, if you want to prove independent, you must check that PA times PB is also equal to 0, right? Okay? Since they are not equal to 0, then A intersect B are not independent. This is just for own enrichment. Okay? So it won't come out. It's just for own enrichment. Okay? But point number 3 will come out. Okay? Point number 3 will come out. So let me go through this review. If events A and B are independent, then your A prime and B are also independent. A and B prime are also independent. A prime and B prime are also independent. So what is the proof? The proof you need to know. So I'm going to prove the first one. A prime intersect B. Okay, if you want to prove A prime intersect B are independent, right, what must you have at the end? What must you have at the end? They must be equal to A prime times probability BI by condition 3. Look at the condition 3. The one that I highlight. A intersect B equals to PA times PB when A and B are independent. So likewise, you want to prove A prime and B are independent and B are independent, PA prime times PB, they must be the same. Clear? Correct? So that is my end goal. So what do I do in between? If you notice, your PA prime intersect D, I'm going to draw a Venn diagram. This is A, this is B. A prime intersect B is here. A prime intersect B. So A prime intersect B is actually probability of B minus probability A intersect B. Agree or not? Okay, so this is my Venn diagram. Draw the Venn diagram. What is PA intersect B? It's actually PA times PB. Why? Why PA intersect B is PA times PB? Because A and B are independent. Okay? Because here, the one that I boxed it up in red, events B, A and B are independent. I wanted to prove A prime and B are independent. Clear? What am I going to do next? I'm going to take out probability B because it's a common factor. One minus PA. So this becomes probability B multiplied by probability A prime. That's sort the order now. Okay. Therefore, I have shown that when A and B are independent, A prime and B are also independent. Okay, they may ask, I don't know, right? They may ask. Okay, right? The proof for the A and B prime, A prime and B prime, they are similar. Right? You can go home and try yourself. Okay, this kind of proving is quite common if you pursue mathematics at university level. Okay, if you are interested, just to let you know. Okay, alright. So please take note. Okay, I'll move on to example 10. 10, 11, and 12. Okay, okay, we are on course. Okay, by the way, is this space okay? If this space not okay, die liao, we are the slowest. Okay, you need to recap on your own at home. Okay, example 10. Okay, okay, let's read the question. Right, PA, B prime given A prime intersect B prime. So this one, I'll draw a Venn diagram because there are no stages. So a Venn diagram would be a good representation for all the information given. Okay. But please take note again, these two terms, the conditional prob cannot be represented in Venn diagram. Okay, the two-thirds can never be represented in the Venn diagram, but I can use formula to decompose it. meaning probability B prime intersect A over PA distributed. And then you ask yourself, where is B prime intersect A? Clear for that? Okay. So for question 10, part 1. Okay. Let me write it down. Part 1. So probability, what they want? Show that A intersect B is 1 out of 18. So probability B prime given A. This is the only conditional prob that I have. The rest of the given information I can't use. So let's try this. Probability B prime intersect A divide by probability A. Where is B prime intersect A? I can represent B prime intersect A. It's here. The one in yellow. Okay? Is B prime intersect A? Where is A intersect B? The one in green. Okay? So let's find what is B prime intersect A first. So probability, sorry. So this 2/3 is equal to probability B prime intersect A divided by 1/6. Okay, so I already highlighted some things for you. Okay, you can try this out yourself. Okay, I'll continue on with example 10, 11, 12. In fact, you can start on your probability tutorial. Okay? Okay, over the weekend. If you have not done your PNC, go and do your PNC. Okay? That's all from me. Okay, Aryan, can you come down for a while? Yes. Okay, the rest, yeah, please, Mefred, please return the attendance list. Mefred, return the attendance list. Sign. Hang on,